Okay, we can start. Okay, this is gonna be the last Lugano Philosophy Colloquia for this year, right? And it's also the last one I am actively organizing. So it's a real pleasure for me to have Vincent as my last guest. From next year on, it's gonna be Byron, and I don't know what is helping you. Okay, Andrea. Okay, so from next year, is gonna take care of this. So it was very nice for me to have Vincent Lam as my last guest. Also, Vincent is a close friend of mine. I would say not super close, but I would say close. We grow. I would love to be even closer. So we met in Grenoble. We even wrote a paper together, which I'm particularly proud of, along with Laurie, the tech. So Vincent is a professor of philosophy in Bern, and today he's going to talk about modeling the Anthropocene and its boundaries. So please, thanks.
Thank you, Christian. Thank you for the invitation. Thank you for being here. So when Christian invited me, I asked him what kind of topic. So typically two families of topic I could speak about. So either philosophy of physics or philosophy of physics, metaphysics of physics, or this kind of thing. And in the end we decided for this kind of thing. So that's going to be it. Modeling the Anthropocene and its boundaries. So the context. Climate change often characterized as the defining issue of our time. There is a number of debates now, less about the causes. This is well settled from a scientific point of view, but there is a number of debates about how to adapt to climate change, and typically to how to articulate the relevant climate change information to address the various types of challenges related to climate change. And from a philosophy of science point of view, crucial questions are about the value-laden dimensions or normative dimensions of this the climate change information. Typically, when it comes to how to deal with deep uncertainties in the climate change information, and at the same time, climate change is now increasingly recognized as being only one dimension of kind of larger, bigger story. The so-called Anthropocene. I'm going to talk about this label in a minute, but it's really about this kind of multidimensional, pervasive, disruptive planetary story about the human impact, the impact of humanities on fundamental Earth system processes, and climate change being one dimension of this. And now the question I'd like to discuss a little bit today is the impact of this kind of bigger picture on the philosophy of science debates on values in science, how to deal with these value-laden normative dimensions of science. And also there is a recent interesting debate also from the Earth system science point of view. We'll be discussing this with an entanglement with a number of various justice dimension in the production of scientific knowledge about this kind of bigger story of the Anthropocene. So that's the outline. I'm going to talk about quickly, in a sense, about values in climate science and modeling. There is a somewhat robust literature now in philosophy of science about the role of values in climate science and climate modeling. So we can discuss this later, but I'll try to be a bit quick about this because it's more well known in a sense. Then I'll address the various challenges when it comes to the proposals to how to deal with these value-laden dimensions of climate science and climate modeling, and then. That's the heart of my talk will be about the deepening of these challenges when it comes to this bigger picture in terms of Earth systems, so-called Earth systems science, beyond a little bit climate science. And then some of these challenges will be about the power structures, the power relationship, the power dynamics that structure, in a sense, the scientific knowledge production, and the concern about justice considerations. That's the outline. Now, there is this big distinction about values in science epistemic values, so-called epistemic values, and non-epistemic values. Epistemic values are typically empirical adequacy, consistency, explanatory power, so the kind of values in a certain sense that enhance the likelihood of the theory, the model to be true in a certain sense, or the values that help advancing knowledge or understanding, these kind of values. And contrary, the non-epistemic values are the social, economic, ethical, political values, and so on. And there is a sort of consensus, I would say, not everybody agrees, of course, but there is a sort of consensus that these type of non-epistemic values are part of current science to different degrees, depending on the proximity, for instance, to socially relevant questions, policy relevant questions. But I think, yeah, it's fair to say that there are a number of good arguments that in a number of sciences, including climate science in particular, these type of values do play a role in the heart of the science. And of course, an obvious worry there is the different biases that could enter the picture when if these non-epistemic values do play a role. Of course, there's a number of subtleties there. The very distinction between epistemic and non-epistemic values has been challenged and so on. But for now, I just want to give you a flavor a little bit of these different types of values. And I'm going to talk about the kind of non-epistemic values mainly in this talk. As I said, there is a sort of consensus, at least when it comes to climate science. Here is a nice paper, recent paper, and Nature comment paper by a number of people from different horizons, including climate science and humanities and social science. And the idea is that non-epistemic values, as I've roughly characterized them, play a role at various levels in climate science and modeling. When it comes to setting the aim and the purpose of climate science and modeling exercise, in the very model construction and development and assessment, how to assess the climate models, non-epistemic values do play a role there. When it comes to dealing with uncertainties, and recently there is an interesting debate about extreme event attribution and various methods in extreme event attribution. And again, there's I think quite convincing arguments that non-epistemic values also play a role there in the context of extreme event attribution. And what is interesting here is that the debate is, or the argument is that non-epistemic values here play a role, not only the kind of external role for the aims or applications in society, but also in the heart of science. Again, in model construction, for instance, uncertainty assessment and so on. So in the internal practice of science. And again, it's a matter of degree, depending on the part of science we are looking at. And a crucial question there is, once we acknowledge this role, this kind of irreducible role in a certain sense, then the question is, what do we do with these values? How do we manage them? What are legitimate roles? What are legitimate values? And so on. These are, I think, now the burning question when it comes to the role of these non-epistemic values in science and in climate science in particular. I'll try to be brief here about this. We can talk about this more in the Q&A. So just climate models very quickly. There are mathematical representation about certain aspects of the climate systems. There are different types of models. You need to discretize the physics there on a grid for numerical implementation. You need initial boundary conditions. And of course, you need to parameterize subgrid processes because you cannot resolve them. And this requires a number of procedures, well-known procedures like tuning, calibration. And all these steps I've just mentioned involves a number of uncertainties. And that's typically where non-epistemic values will enter the picture. Again, as I said, I'm going to be very fast about this because it's not the heart of my talk, but just to give you, again, a flavor a little bit, a sense of how things goes here. Here is an example about the role of non-epistemic values in parametrization when constructing, if you want, the climate models. There are different ways to represent processes. For instance, when it comes to convection, to subgrid processes, so you need to parameterize them, and there are different ways to do this. And choosing between these different ways is not a matter which is settled by data, by empirical data. Hence the number of so-called non-epistemic again values enter the picture here. And one step in this parameterization process is this calibration process. So adjusting poorly constrained parameters such that discrepancies between the model outputs and the selected observations or data is minimized. But again, the target of your calibration or your tuning process is a matter of choice, again, which can be influenced by a number of non-epistemic dimensions. For instance, here I give the example from this paper about whether you want to optimize ocean heat transport or in the North Atlantic or tropical convection. And these are typically very important climate processes that it will influence would be fundamental important for different regions of the world. Whether you're interested more on the climate projection for Europe, for instance, or whether you're interested in climate processes or projection for around the equator, for instance. And then depending on your interest there, regional interest, you would want to tune, to calibrate different or optimize different processes. Here is a quote about these kind of values then having an effect on the output of the models. None of the current generation of global general circulation models was built in Africa, for example, and the relevant processes operating there have not always been the first priority for model development. So typically there, the claim is that since most of the big modeling centers are in the global north, so these people tuning, calibrating, making the parameterization have certain interests when it comes to optimizing certain parameters of certain processes for certain regions and so on. And there you see that there are a number of epistemic trade-offs, and these epistemic trade-offs will be influenced by, again, non-epistemic values, which would, in this case, include just your regional interests, the kind of interests which are which depend on where you are and the regions you are interested in. So here's just a very quick example. Now the big question, there is a lot of work about trying to describe the different roles of values in the process of producing this climate change information. And then the question is, once it's acknowledged, is what do we do with these values? Hence this question of how to manage these values. Here's a quote from Kevin Elliott's working on this question: to abandon the value-free ideal. So again, this kind of intuitive picture that one might have about science being value-free. To abandon the value-free ideal is not to go for free for all, in which values of all sorts are accepted in every part of science. We need strategies for managing these values and considering which values are appropriate in which case, and that's really the heart of the debate now. Which values are appropriate and in which case. So it's not free for all. We need certain conditions for managing these non-epistemic values in science. And there are two levels here. There are the levels of the influence of values at the level of the individual scientists, and of course at the bigger level of the institutions. Again, there's an important literature on this. I just here highlight three broad conditions that capture, in a sense, a number of ideas about the possible legitimate roles of values in science. One condition, there are broadly three conditions here, three families of conditions in a certain sense. One is about transparency, so making explicit the underlying values and value judgments. The second is about representativeness. You want somehow your values to encode our major social or ethical priorities in a certain sense. And the third one is about, generically called by Kevin Elliott, engagement. So engagement between an interdisciplinary area of scholars, so within science, and also a diversity of stakeholders. So the people typically which in the case of climate change information, the people who will be impacted by the production of your climate change information. So taking their interests, their values into account to promote critical reflection. That's about the interdisciplinarity within the scientific community. Of course, I think there is an agreement also that it's going to be very difficult to come up with a set of necessary and sufficient conditions here for legitimate values, for instance. But at least there are sort of guiding principles there: transparency, representativeness, and engagement. Of course, when it comes to the global scales, like issues related to climate change and climate change science, are going to be a number of difficulties to implement these conditions. Typically because of the global scales. But now there are a number of aspects which can a little bit alleviate these difficulties. One is the argument that a number of these value-laden choices, typically the one in the context I've just mentioned about parameterization, have been argued to be actually to boil down to certain pragmatic factors. It's not about, of course, there are a number of non-epistemic dimensions entering the picture, but in the end, we could say that a number of them are actually very pragmatic. You do with the kind of things you have at your disposal at the moment you develop your climate model, for instance. Another proposal for alleviating a little bit these difficulties is a number of democratic mechanisms which have been proposed in order to select legitimate values, including, for instance, the various stakeholders, the interest and the values of the various stakeholders, which will be, as I said, impacted by the production of your climate change information. Here, there is a number of papers by Wendy Parker and Greg Lust in the context of climate services. So this is a booming industry now, but it's in general still at the kind of local or regional scale, not at the scale of the entire planet. So it's easier in a certain sense to identify the stakeholders in local region or for local communities, people who will be impacted by adaptation measures, for instance. And again, there are also various initiatives to co-produce, so-called co-produce usable, actionable climate change information. I'm part of an international scientific initiative from the World Climate Research Program, My Climate Risk. So the idea is trying to produce climate change information from the bottom up rather than top down. We organized a workshop in Bern the last fall with some of these people, with also scientists from the Global South, trying really to put together our forces in order to produce climate change information, and from the philosophy of science perspective, trying to implement, in a certain sense, these conditions in concrete cases. Now, this is all fine. There are different, as you see, there are different proposals to alleviate these difficulties. But I think in general, when it comes to the global scale, I think it's fair to say that there are still serious challenges in order to implement these conditions for legitimate walls of various types of non-epistemic values. And now the claim here is that this, in a certain sense, it even gets worse when we take this kind of bigger perspective, when we consider that climate change is only one dimension of a larger set of disruptive human interferences in fundamental life support planetary processes, what is called typically the Anthropocene. And this is characterized within the framework of Earth system science. And my claim is that this deepens, in a certain sense, the type of worries I've just hinted at in the context of climate change for the question of value management, managing the role of non-epistemic values in science. And yeah, it's also, these questions are also central. I'll be discussing this at the end of my talk. It's also central when it comes to integrating a number of justice dimensions in the production of scientific knowledge about the Anthropocene. Okay, the Earth System Science Framework is about, so it's going beyond climate science in a sense. It's the ambition, the grand ambition, is trying to provide a unified understanding of the Earth as a unified, complex, adaptive system. And the crucial point is that it's explicitly about including human and social processes. Ultimately, the ground ambition is on a par, if you want, with other physical Earth systems, systems. It's a kind of new, in this sense, a kind of new conceptual framework. It has been coined the second Copernican revolution by Sheldon Huber, for instance, a physicist working on Earth system science, and it had roots in a number of geographers, biologists like Humboldt, of course, Vernadsky, Lovelock, and Margulis, this famous Gaia hypothesis. This is a little bit the roots of this novel conceptual framework of the Earth system science, which is quite recent. It dates back in the last 2 or 3 decades in its kind of contemporary mathematical physical form. And the ambition is quite grandiose in a certain sense. Here's a quote from this literature: human societies, that culture, the knowledge, artifacts should now be included on equal terms in a new family of models to conduct systematic global analysis of the Anthropocene. So the idea, it's not done yet, of course, but the idea is ultimately to model everything on a par. So human social processes on a par with physical processes, the Antarctica ice sheet, the climate system, of course, forest, and so on, to have a kind of integrative understanding of the Earth system. And the big challenge is to fully integrate human dynamics, again, this grand ambition, as embodied in the social sciences and humanities, with biophysical dynamics to build a truly unified Earth system science effort. And of course, it's going to be a need for interdisciplinary there. We've argued with a colleague that it's going to be problematic. I'll be talking about this, and it's bordering something which is called in the literature scientific imperialism, in the sense that you have natural sciences invading the domain of social science, humanities, in a certain sense, and imposing certain methods. And this can be epistemically detrimental. I'm going to talk about this a bit later. Here's a kind of conceptual model updated from a very famous conceptual model from a NASA scientist in the 80s. You can see here the idea. You have here on the left the various Earth system subcomponents, the climate system, the ocean, of course, the biosphere, and then on the right-hand side, the so-called anthroposphere. And you have they try to disentangle various aspects of the anthroposphere, so energy system, knowledge, science, technology, institution, politics also, human populations, so cultures, values, beliefs, or values typically, and various feedbacks and dynamics, inequalities. And then the idea is to understand the feedbacks between these physical subsystems and the social human subsystems in order to have, again, a unified understanding of the entire Earth system. So very, very ambitious in many ways. Now, this notion of Anthropocene is really coming from this within this conceptual framework. It has kind of dual origin. One is clearly in geology, in stratigraphy. It's a proposal. Technically, it's a proposal for a new geological epoch following the current Holocene, so a bit more than 11,000 years, and characterized, of course, by the impact of humanity in the geological data. This formal proposal has been put forward by a commission after work of more than 10 or 15 years. It has been formally rejected by the Stratigraphic Commission, so the geological institution working on these questions last year. Again, it's a very formal process within geological sciences. It's not so surprising in a certain sense. The starting dates, there are a number of questions and very interesting debates, value-laden debates about the starting dates of this geological epoch. There was debates, and then they settled on the 1950 for a number of reasons. And of course, from a geological perspective, this is extremely recent. And so for various reasons, it has been rejected. Now there is the Earth system science perspective on this notion of Anthropocene, and there it's characterized as a kind of new state for the entire Earth system. So you take the Earth system as a physical system, and it's a new state for this physical system, characterized by, again, human activities, typically the saturation of the Earth's biogeochemical and physical capacities to maintain resilience because of human activities. And you have these type of figures where you have here in the state space, in a certain sense, you have the stability here, and you see that's the in a certain sense we are moving away from certain stable conditions for the Earth system. And this is characterized by a number of parameters. On the left-hand side, you have the socio-economic parameters like population, GDP, water use, and so on. There's many more. And the right-hand side, you have those kind of physical parameters like carbon dioxide, surface temperature, ocean acidification, tropical forest loss, and so on, nitrogen, and so on. And there's many more. And the idea is here that you can see that there's this kind of almost exponential trend starting from the mid-20th century. Hence, this was also the argument for dating the start of this potential new geological epoch from the 1950. Now, very briefly about the main arguments for this new state for the Earth system. Of course, climate change is one dimension of these set of arguments. Another one is the massive degradation of the biosphere, the so-called collapse of biodiversity. Typically, you have here a report from the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services from 2019. So the equivalent of the IPCC for biodiversity is more or less one of the results of this report. The rate of species extinction is tens to hundreds of times higher than the average over the past 10 million years. And it's accelerating. The trend also is extremely concerning. Another aspect is about the profound perturbation in the fundamental, again, life supporting geochemical flows of water, nitrogen, and phosphate. The proliferation of novel entities, so microplastic, forever chemicals, antibiotics, radioactive waste, and so on. And land system change, and so on. And there's a number of other dimensions. So all this together makes the case for defining this new state for the Earth system. Now, within this conceptual framework of the Earth system science, there is this notion of planetary boundaries, and the aim is to delineate the biophysical and biochemical systems and processes known to regulate the state of the planet within ranges that are historically known and scientifically likely to maintain Earth system stability and life support systems conducive of the human welfare and societal development experienced during the Holocene. So this is from one of the latest paper on this topic of planetary boundaries. But what is interesting here, you see that there are clearly explicitly normative and value-laden dimension when we talk about human welfare and societal development and so on. And they are explicit about this. Here's another quote from this literature. The framework establishes global boundaries, which, if transgressed, substantially increase the risk of a change in Earth system functioning and/or its long-term state and trajectory. Thus, it addresses the risk of steering the Earth system out of relatively stable, favorable conditions, and in doing so, defines a safe operating space for humanity. Again, you see, it's extremely explicit. There's this notion of risk, of course, value-laden notion, favorable conditions, a safe operating space, and for humanity as a whole. Of course, there's a number of value-laden, explicit value-laden dimension here about typically what does safe mean here. Here is a typical representation of these planetary boundaries. Part of the success also of this notion of this conceptual framework of planetary boundaries comes from this kind of graphical representation, very easy to convey in many ways. So you have here the various dimensions of the 9 planetary boundaries, so climate change, biosphere integrity, land system change, freshwater change, biochemical flows, ocean acidification, aerosols, ozone, and novel entities, plastics, and so on. And then you have boundaries here, which delineate this safe operating space for humanity in green. And you see that along a number of dimensions of boundaries, we are transgressing the boundary to a increasing risk zone or even high risk zone when it comes to novel entities and biosphere degradation. And there is a number of publications about this topic. Typically, there are three big updating of this. This is the latest one, and of course the trend is clear. According to this literature, the transgression is worsening over time, very quickly. Now, the values is quite explicit in this framework. So if that is going beyond the sole focus on one dimension, like climate change, for instance, and this framework helps to characterize again this multidimensional nature of the Anthropocene. And of course, there are, as I said, there are strong normative and value-laden dimension to this framework. So determining a safe, as I said, this notion is, this is one of the first paper on this topic, safe operating space for humanity, highly involved normative. This is a quote even, involve normative judgment of how societies choose to deal with risk and uncertainty. So they are quite explicit also from one of the very first paper in 2009. But then, of course, they leave it open on how to deal with these normative and value-laden dimensions of their work. It has been highly influential in many ways. It has inspired countless scientific publications and consequently civil society initiatives, business practices, and policy implementations. For instance, in Switzerland, we voted this spring about an initiative which was more or less based on this notion of planetary boundaries. It has been rejected, but the initiative itself was based on this notion. Okay, the type of questions one might ask about this value-laden dimension is who decides these thresholds. They are clearly not only purely physical thresholds. Again, they involve this notion of risk, of safety, and so on. Who decides what is safe and for whom? So how should uncertainty treated? There along all these dimensions I mentioned: biodiversity, climate change, of course, but land system change, water use, novel entities. There are going to be more or less various types of uncertainties. How do we treat these uncertainties? Some of them can be quantified, many cannot be quantified. So how do we treat them? What attitude toward risk when it comes to these different dimensions, and the implementation, the possible implementation of the precautionary principle in this context? What about the different trade-offs between the planetary boundaries? It's clear that it's going to be impossible in many ways to respect all of them. So and this is typically something they can see in the public debate. Maybe should we privilege climate change over biodiversity, or vice versa, and so on. Same for the other dimensions. People will be, depending on the region, people will be impacted differently, and so on. So there are a number of trade-offs there which involve non-epistemic values, again, in multiple ways and at different scales. So global scales, regional scales, and so on. And I think there is an urgent and critical need now to seriously address this question of values in this context. Again, think about how influential this type of framework is. And again, with the increasing impact of these different dimensions when it comes to extremes and so on, this will be more and more influential in many ways. People will acknowledge the need for this kind of threshold in a certain sense to be respected, but then these questions need to be seriously addressed. And for now, in effect, it's currently decided by a very small number of people in the University Professor for the Global North. So it's quite interesting how consistent the group of people who produce all these papers is. It's a very small number of people in the end producing this highly influential conceptual framework. And again, there are difficulties to implement the conditions I've mentioned about transparency, representativeness, engagement, again, at this planetary scale, and when it comes to this multidimensional nature of the Anthropocene. And one aspect I'd like to emphasize a little bit here is that there is a kind of blind spot in a certain sense in the philosophy of science debate about value management, I have the feeling, is that we need, especially in this context, we need to seriously address the various aspects which are related to the power dynamics structuring the scientific knowledge production here about in this, again, multidimensional planetary scale context. And it's also closely connected to a number of justice questions related to justice issues. And actually, interestingly, this has been explicitly acknowledged in this literature. Now they're talking not only about safe operating space for humanity, but safe and just. They have been updating a little bit their framework in order to explicitly include this reflection about this justice dimension. But again, what is interesting is that you cannot really read, but you have, again, Johan Rockström was one of these main authors from the very first paper in 2009, and they're still there. Again, it's quite a small community producing these works. But still, they want to include these interesting reflections about the justice dimension. And so there's this kind of recent incorporation of justice perspective in this Earth system science framework for planetary boundaries. And the aim is, this is a quote, quantify safe and just, so not only safe, but also just Earth system boundaries that minimize human exposure to significant harm. And of course, they draw on the literature about justice, and there is a number of justice dimension. Here are 3 justice criteria. They want to operationalize in their framework. One is interspecies justice, intergenerational justice, and intragenerational justice. And the idea is trying to operational these notions in order to define not only safe boundaries, if you want, but safe and just. And most of the time, all the time, the newly defined safe and just threshold will be below the purely safe threshold. So the idea is, again, I didn't mention that, but in order to, of course, in order to define these boundaries, you need to identify critical variables, and you need to define a kind of critical value for this variable as a boundary. And then, including now this justice dimension, you will lower, in a certain sense, the value of this for this variable, defining your boundary. So interspecies justice aims to protect humans. This is a characterization from one of these papers. Other species and ecosystems, rejecting human exceptionalism, as they put it. Intergenerational justice examines the relationships and obligations between generations, such as the legacy of greenhouse gas emissions or ecosystem destruction for youth and future people. And intragenerational justice includes relationships between present individuals, between states, so international, among people of different states, so global, and between communities, community members and citizens, so in communities, communitarian on nationalists. So you have these different justice criteria, and then they try to operational them in within their system boundary framework. And now the question is, again, the trade-off between all these different justice criteria and so on. Entangled with what I said before, you have a bunch of dimensions which are highly normative and value laden, and the question is the same: how do we deal with all this? And here the idea is that maybe the philosophy of science debate here needs to go a little beyond its usual apolitical, in a certain sense, way of doing, and then to engage explicitly with the various power dynamics at play. So trying to here argue for a type of there is an explicit refusal of the thing, no politics. kind of political philosophy of science in a certain sense. So the three justice criteria interact in a myriad of ways within the with the different with the different planetary boundaries at different scales for different regions and contexts. Imagine this framework of planetary boundaries has been typically downscaled for Switzerland, but you can do this for all regions of the world, and then everything interact in different ways, and you have different trade-offs depending on the regions and so on. So there is going to be a mess in a certain sense. And in this context, in this very complex context, the value management debates, typically in philosophy of science, I think need to address issues related to this, to power dynamics, and in particular to the question related to so-called epistemic injustices and what is called recognition injustices in the literature. And this is also explicitly acknowledged by this very literature on planetary boundaries. Here's one of the latest paper on this Earth system justice framework. So it's not only natural scientists from Earth system science, it also involves also a number of social scientists. Here's a quote: "We also recognize that we have not adequately addressed recognition justice by including a broader representation of scholars and interested people in our selection of boundaries and research." Remember, the whole thing is going to be highly normative in many ways. For the entire, the ambition is grandiose. It's for the entire planet. And here they are clearly, despite this big ambition, they clearly acknowledge that it's going to be difficult to involve all the stakeholders, the people, interested people, as they put it. Recognition justice or injustice first occurs when powerful interests, for example, countries, corporations, dominate national to global level decision-making on environmental issues and decide who is involved. Again, this is from the other, their characterization from the other paper I've mentioned. And the epistemic injustice occurs when different sources and types of knowledge are ignored, their credibility is questioned, or access to different types of knowledge, including traditional and indigenous knowledge, is blocked. So addressing these different types of injustices is, the claim here is addressing these different types of injustices is crucial to this whole exercise. And these type of injustices may lead to what Brandon and et al. Here call the effective suppression of solution path embedded in a plurality of ways of inhabiting the world. The idea is that if these different types of ways, different cosmologies, if you want, or different values, interests, and so on, are not explicitly included in the debate, then of course you have dominant ways of inhabiting what is called inhabiting the world, namely about the humans, also society-nature relationship, which are going to be dominant. And from a justice perspective, it's highly problematic, and it's also highly problematic in order to implement the type of condition. Think about representativeness I've mentioned at the beginning. And there is also a very good argument that different ways here of what again here mentioned inhabiting the world could define again a solution space or a space of possibilities which is relevant to address all these issues in the first place, and that in this kind of dominant space of possibilities we are evolving in the kind of knowledge production we are standard knowledge production. There is an argument saying that there's a number of dead ends. For example, different assumptions about economic growth and so on, which are all over the place in mitigation and climate scenarios, for instance. So addressing these injustices require interdisciplinary engagement with a range of different fields. And in particular here, I'd like to highlight the work on decoloniality, so decolonial perspectives in social and critical social sciences, which can be highly relevant when it comes to, again, at the global scale, treating these different power dynamics, also which have histories, lineages in a certain sense, that still structure the type of scientific knowledge production. Again, the paradigmatic example is the mitigation scenarios used by the IPCC, We can talk about this in the Q&A. But for instance, almost all of these scenarios still assume certain forms of inequalities in the future between global north and global south. So you assume that in the future, at the end of the 21st century, 2100, people in the global south will consume less energy and so on. And this, on what basis, this can be, of course, challenged from these decolonial perspectives. Okay, summary, and then we can move on for the discussion. I think issues like climate change, but more broadly, the different challenges related to the Anthropocene challenge the question of this issue of value management, especially when it comes to scale. And I try to argue that the multidimensional, pervasive nature of the Anthropocene further deepens this challenge. And yeah, climate change being only one dimension among these several planetary boundaries, and all this will involve uncertainties, risks, and trade-offs. Again, involving a number of value-laden dimensions. And all this is then interrelated with a number of justice dimensions. And I've gestured a little bit, trying to argue that the standard philosophy of science debate about how to manage in a legitimate way these the role of these non-epistemic values in science now needs to address to face in a certain sense this kind of power dynamics that structure the scientific knowledge production, especially in this context. And this is a kind of, to me, it seems like kind of blind spot of the current philosophy of science debate when it comes to this notion of value management questions. So we need some form of political philosophy of science in the end. And this requires true interdisciplinary engagement beyond the kind of, I just mentioned this notion of scientific imperialism that it's sometimes at play between natural sciences on the one hand and social sciences and humanities, and using qualitative methods, for instance. Here's, just finish with this, a quote from Jürgen Renn, Story of Science book. In confronting the Anthropocene, we should reorient the current, this is right at the end of this big book, the current knowledge economy towards global responsibility, and that this transformation will have to include the interlocking of multiple knowledge dimensions and critical engagement with the entanglement of knowledge with political, economic, and moral issues. These are the hallmark of science in the 21st century, according to him. And I brought here some snow in the distance from the valley, just the other side of the mountains, a few weeks ago. Thank you very much for your attention.
Question, we start from the students. Yeah. Hi.
Yes. So I have two questions.
Yes.
First is when it comes with non-epistemic values. So non-epistemic values, as far as I understood, they are socially constructed, right? And yeah, so when it comes to creating a framework that includes also non-epistemic values, would you consider a co-fair approach that tries to say that you track physical properties of physical properties and confer to them non-epistemic values or social values?
So what is exactly the question?
Yes. If a confer approach is compatible with what you said.
I guess in principle, yes. I don't think it's the main point, but I guess yes, in principle. And again, think about when think about theory building in general. You might want to have certain features for your theory and so on. And these features, the claim here is that just that some of these features will be influenced by, again, certain social, ethical consideration, more or less as a matter of degree. When it comes to high energy physics, of course, less so than when it's about policy relevant science. That's just the idea. I think there is a sense in which it's fairly basic what I'm saying about this. But it's just that if you want to keep this kind of value-free idea of science, which is again very appealing in many ways, then you have a difficult time when it comes to a number of sciences. But maybe I've answered beside the point, your point or your question, or. But to answer your question, is in principle, yes.
Okay, thank you. The second,
Yes.
it's a little bit more specific
Yeah.
about the different forms of injustices that you mentioned.
Yes.
Would you admit a form of intersectionality between the various kinds of injustices? So, from a business perspective, the injustice, they are when it comes with environmental issues. The kind of injustices that are they face not just reduced to recognition injustice or just epistemic injustice.
No, you're perfectly right. No, fully agree. No, I fully agree. Yes, somewhere I have there's in the literature there is a list. There is a number of different. It's only a few of them. There is a number of different dimensions of justice notions that we could articulate, and you're perfectly right. I don't think we can reduce to any of them. It's this notion of intersectionality is I think it's fundamental. In the same sense, I don't think we can reduce the kind of injustices that certain communities and so on face to just sort of environmental question. It's always interrelated to social dimensions, political dimensions, and so on. Yes, you're perfectly right. So this notion of intersectionality is crucial. Yes.
Thank you very
Definitely. Thank you.
Yeah. So there's an interesting sort of self-referential nature at the very end, because epistemic injustice, for example, has already been theorized by those communities themselves, by indigenous communities themselves. They have already sort of understand that they are in a certain kind of relation to science. When I say science, I mean Western science. So it seems like at least that a political philosophy of science, when it addresses such questions, must itself be decolonial to even sort of begin to speak on such, whether it can adjudicate between relevant sources of knowledge and so on. So it seems like we need also to sort of embed philosophy of science, but I mean, loosely speaking, epistemology perhaps from other sorts of systems which we must sort of deal with together.
Yeah, you're perfectly right. And that's why I've tried to highlight a little bit this notion of interdisciplinarity in many ways, so that philosophy of science itself shouldn't just evolve in a void. You're perfectly right, and should interact with typically I highlighted a bit this decolonial perspective. I think it's fundamental, but again, it's a huge topic. How exactly? I think it's really work which needs to be done in the future. There is a lot of work to be done there. But yes, you're perfectly right. It concerns also the very philosophy of science. And now I think there's a growing debate about this notion of transdisciplinarity and the role of philosophy of science there. And I think again, I don't think you can escape this kind of question about justice and decoloniality more generally, even for philosophy of science itself. You're perfectly right. Yes, no, I think it's a big topic. Yes, thank you. It would be just to comment. It would be weird to have this kind of discourse in a certain sense and have then a small number of philosophers of science from certain region of the world telling the rest how to deal with knowledge and epistemology and so on. Of course, no, you're perfectly right.
At least idea how much.
Yeah, of course, then that's the whole problem. That's we do not evolve in a void. academia, for instance, you put example, there is a whole topic about decolonizing academia, for instance. It's a huge topic, and there is no easy solution. But I think starting already the process also within political science, I think it's very important.
Students, or we can open up to everyone.
And people online?
There's people online.
Okay.
I have 72 questions, but I will have to wait until the end. I start with one, and then maybe. So I start with one general one. This is not specific. The other ones are kind of, but this is very general. And I don't know if it's kind of a critique or could be. So my point is that I understand very well why you're proposing this, or well, why you agree with proposing it, and why you yourself are proposing this. And I think I see the argument, but there could be a potential risk that some people may have of having political philosophy of science in general. And I think not just that, but some of the attempts you were trying to do of kind of mixing considerations about climate science and considerations about other injustices, for instance. As much as I could agree as an individual, I could agree with you. I think that if I look at this issue from a broader perspective, and I notice that I think everyone would agree that there is one difficulty is precisely to make people understand that this is not something that scientists think about, it's something real, it's something that it's objective, it's not subjective, it's not political. So the risk I see in this is that since they are already kind of, some people are already looking for excuses, this seems to be giving them a lot of excuses.
Yes.
So this is a critique.
No, I don't think it's a critique. I think it's a well taken point. It's something which is acknowledged. I think it's social in critical social science that you need to be clear about what is your targets and what are your aims and the possible dangers in a certain sense with highlighting these aspects. But I think what is I don't think we can put this under the carpet for a certain political agenda of efficiency or whatever, because then it will just fire back. I think it's crucial to have a better understanding of how science works and how science is produced, but without being naive. I mean, there's this very famous work about the various types of vested interest which influenced science climate skepticism, for instance, by Naomi Oreskes and others. This is well known, and I think this needs to be acknowledged. But again, this is, to me, this is part of a better understanding of how science works, and the strategy of saying maybe we should put this under the carpet and go for a value-free science in order to not to open the flank to these type of objections, or I don't think it's again politically a good strategy now.
So yeah, thank you. Two things. So one is I wasn't thinking that it's a strategy just to to put that under the carpet, just to kind of have better chances. There's definitely you may think that there's kind of an urgency to the problem, and you know this much better than me. So if you think that there's an urgency, again, if you start to prioritize, you may think that it could even be, I'm not saying that it is, but it could be something to discuss, whether putting those issues under the carpet for now, it's a good strategy to prioritize. First thing, well, sorry, John.
No, this is a very good point, and this is something which has been highlighted also. And I think there is a very interesting debate about this emergency regime, and I think there are also very good arguments saying that it's also very dangerous, because emergency regime, this is again a political notion, and this is a way to suspend all type of debates. And under emergency regime, climate emergency, and so on, you can do anything.
We saw this before.
And yeah, basically, and this is super problematic. And when you have to face such fundamental existential deep, complex issues like not only climate change again, but the Anthropocene, these different dimensions. I don't think that's the kind of emergency way of thinking is the right one. Even if time is pressing, clearly you're perfectly right. But suspending debate, I don't think it's a good option. Again, there is a geographer from Cambridge, Mike Pohl, has written, and others have been writing about this. I think it's quite convincing as an argument that this type of emergency framing is problematic in a number of ways. Now, as an activist and so on, you can make an argument that you want to push this. But again, from a philosophy of science perspective, when you take into consideration these type of dimensions I've mentioned, I think we should be very careful and critical when it comes to invoking this type of emergency epistemology in the end.
Okay, totally agree with that point. The other small thing was about, like, you were kind of, I think you were big on this, but for good reasons. But how much how sure can we be that the kind of that there's no way to make fairly good, fairly justified claims about some parts of the climate issues without being almost certain that there is almost no epistemic value? Because you seem to be saying, well, obviously there are no epistemic, but I mean, I would say that we should still try and look for the ideal case in which at least some of the things. I remember the taking point thing. This seems to be something that is, well, I mean, ideally this is a concept that we can talk about without involving any, well, idea. But yeah, sorry.
I think the tipping point case is a bad example because it involves deep uncertainties.
Okay.
So there's a lot of uncertainties about tipping points, and then you can frame this in different ways, depending on basically on your agenda. But it doesn't mean that it's scientifically irrelevant. It's highly relevant as a concept, but again, you should acknowledge these dimensions. It's highly uncertain. We need to take decisions under high uncertainty, deep uncertainties. It does involve a number of value-laden dimensions. But then the question, which is a question of how to deal with them, not to say that ideally we should avoid them. I don't think it's the right way to go. And about the other, your first point, I think that's the central question. I think yes, of course. It's a matter of degree. The point here is not to say that this whole literature is not saying that all scientific knowledge production is just, remember the quote by Kevin Elliott, it's not that anything goes, not at all. There is a number of epistemic constraints, and this alleviates also maybe your first worry about climate science, for instance, and climate skepticism. There is a number of epistemic norms, for instance, for good science, of course. And you can then invoke these epistemic norms to show that the science put forward by the kind of skeptics is just bad science from an epistemic point of view. That's one thing. Now back to your question. I think it's a matter of degree. When we're talking about global claims like the anthropogenic cause of the observed increase in global mean surface temperature, non-epistemic values are playing a very, very small role there. It's mainly about pragmatic questions and so on. It's extremely close to what we could call a value-free ideal in a certain sense. There's a debate there to be had again, but that would go a little bit in your direction. But then when it comes to questions about adaptation or mitigation or adaptation to climate change, given again the high, deep incentives involved. There's the notion of risk. There's the notion of different attitudes you might have with respect to risk, or to deal with uncertainties, depending on your attitude with respect to risk. All this is highly value-laden. And if you don't acknowledge this, then again, you're back to this idea that it's a top-down thing, and there are certain people just running big models and telling people what to do all around the world. And this is again, there are very good arguments that it doesn't work. And it doesn't work not because people will be worse off, that's the case, but also epistemically. You just produce epistemically less valuable knowledge.
question the line? Yeah, go.
Hi.
Hi.
Hi, thank you for the very rich talk. So my question is actually very related to the last question. So we all agree that value plays an important role in science, and there's of course the value that plays a part in terms of motivation of what kind of inquiry we are going to do, and the kind of values that are involved in the actual process of knowledge production. But the way that you seem to emphasize is close to the more popular view in the philosophy of science recently, that value, even in the process of knowledge production, value can non-epistemic values cannot be are deeply entangled in the process. But that of course raises an important risk of discrediting the objectivity of science, in the sense that people who don't necessarily agree on the non-epistemic values, then there's not even a point to claim that the knowledge that you produce has any relevance to these people.
Yes, thank you. Again, remember the quote by Kevin Elliott, it's not like anything goes. It's not like you can just come up with a set of values, whatever they are, and then just produce science. We can reproduce the increase in global mean surface temperature or any kind of empirical data. That's not the case at all. The fact that we can, there is a number of epistemic constraints, they're highly robust in many ways, but it doesn't mean that there is no influence of non-epistemic values. But on the other hand, the fact that non-epistemic values do play a role doesn't mean that, again, anything goes. It's that just by having certain values influence in a deterministic way the outcome of your scientific knowledge production. That's not at all the case. And again, the best example is climate modeling. It's
yes,
actually,
but I think that I think there are two different ways of framing this, right? So one way is to say that value is everywhere, but there are some epistemic constraints. So it's the first claim is that you cannot disentangle value. Any value is everywhere, but there are epistemic constraints. If that's the message, I'm just worried that if this is the message, if this is a better message to convey than to say that there are some very solid epistemic core of the knowledge that you're producing, on top of which, if it comes to the policy making or further down the way, that there are values that you need to consider. So
yes.
you think that the first message is better, that value is everywhere, but there are constraints. But these doesn't. But arguably, some people were saying that this may not be the better message to convey.
Okay, I understand. I think it's very close connected to the previous question. But again, I think that there are good arguments. Again, it's a matter of degree, as you just mentioned, and as I also mentioned earlier, it's a matter of degree, depending on how close you are to the science policy boundary, for instance. Certain types of non-epistemic values could play a bigger role. But again, all this doesn't mean that anything goes. I think this is pretty clear. But if we don't want to acknowledge, I think it would be wrong epistemically wrong not to acknowledge the role of these different types of non-epistemic values. And again, there are people who even are very critical when it comes to the very distinction between epistemic and non-epistemic values. And if you don't draw this boundary between epistemic and non-epistemic, then it seems that again it's a matter of degree. And again, there are very good cases at hand that show that these values do play a role. And but again, it doesn't mean that anything goes.
Thank you. So we have one more question online, right? First I have Lorenzo, then online, then Philip. Go on.
Yeah, I guess at this point you kind of addressed already my question, but it's a question about epistemic injustice and scientific method. So, like in the general debate with knowledge about epistemic injustice and the way that the notion was brought up, I understand why like cases of epistemic injustice are really bad because like we are kind of undermining certain social groups just due to like prejudice, for example.
Yes.
But I was wondering if really want to take into account these issues related to epistemic injustice in this debate, in this kind of issue. Can we do that without like putting into question like the scientific method in general? And especially, I guess my curiosity was if you have any example of like any kind of like any way in which this could be useful. If there's like one example of like a notion you can bring in and use. Yeah.
So your question is whether I have an example where dealing with epistemic injustice could be epistemically useful, something like that, or
Yeah.
there are a number of examples. Yes, yes. Okay. All the examples. I'm no specialist at this, but all the examples are the very pragmatic example are typically in the conservation science of biology, where typically you have a body of knowledge about species or something, and then this will lead to certain regulations, adaptation measures for conservation, typically under certain constraints. And then you see that in a number of cases, local indigenous knowledge put this under different lights. And then in the end, combining the two or different types of integrating, or again, we should be very careful when it comes to the decolonial questions, but dealing with this notion of epistemic injustice when it comes to this indigenous knowledge or local knowledge, then leads to better conservation measures. So in the sense, if the purpose of your knowledge production in this case, if the metric, the measure would be species conservation, certain species conservation, then integrating this type of knowledge or dealing with this epistemic injustice with respect to this type of knowledge leads to epistemically better knowledge in this sense. That would be I think a clear example that I could think of in the literature.
Yeah, so we can kind of embed these like scientific without needing to revise it. Oh.
In practice, that's more or less what very often happens. Typically, yeah. But again, there's a number of worries there. What it means to embed, what are the standards, and I think your underlying question when it comes to the scientific method, I think it's a genuine one. I think it's and there, I don't think there is an easy answer there to how to combine a certain epistemic framework about the scientific method or whatever, and then addressing these type of worries about epistemic injustices. I think it's there are several questions there, and it's a subtle, difficult debate, and I don't think there is an easy answer. And maybe my take on this, again, it's an ongoing debate. I would be a little bit worried or cautious when it comes to trying to come up with a kind of global general solution to this question and trying to develop a general framework applying for all cases where you say, okay, this is the scientific method updated in order to address epistemic injustices everywhere. And this is the scientific method 3.0 or update. I could see why I would like to do this, but I would be very worried, in particular for issues like that, for instance, decoloniality in this kind of thing. But again, back to your original question, I think there is a genuine phenomenal debate there. And again, I would just briefly mention this meeting we had in Bern with the people from this My Climate Risk activity from the World Climate Research Program. So essentially, we're climate scientists from the women climate scientists from the Global South. And again, this is an ongoing debate. The fact that and that's where typically climate scientists, so already embedded in what some people would call the Western science framework. But these people were also facing a number of issues, injustices, and in the knowledge production, and addressing this question again. It's an ongoing debate. Thanks for the question.
Hi, thanks very much. I enjoyed the talk very much. I'm writing on issues in sustainability, and I think I'm running into some of the questions and issues that you're addressing here. My question might be somewhat related to the last question. I wasn't quite hearing everything, but I was wondering if you could provide an example or even just a sketch of what model construction or development might look like if we take seriously issues of epistemic and recognition injustices. For example, with respect to the planetary boundaries and the current effort to unloose those from the global north, what do those efforts look like once we start incorporating the questions of epistemic and recognition injustices from the global south?
Thank you for the question. That's a big question. I don't have any easy, quick answer to that. Some people may even question the very framework in the first place, saying that it's the global ambition of the whole planetary boundary framework is problematic in the first place along a number of dimensions. That's one possible worry. But I think one way to go, maybe to go a little bit in the direction of trying to answer your question, is through interdisciplinarity. So including diversity of scholars, for instance, from various fields, who could address the different dimensions related, including justice dimensions related to planetary boundaries, and also to the downscaling of these planetary boundaries to different contexts, regional contexts. You need specialists from these different contexts and so on. So again, this true interdisciplinarity, maybe sometimes leading to some form of transdisciplinary. I think this is something which is fundamental, going a little bit beyond the disciplines and the silo way of thinking in terms of these boundaries separated from one another, and looking at them purely from a system science perspective. So having first a kind of more open debate, including an interdisciplinary, diverse array of scholars from various disciplines, including the critical social science, humanities, and so on, relevant for the questions at hand, would be one way to go a little bit in the direction of trying to answer your question. But I don't think there is any easy answer to this question. But in interdisciplinarity, so involving people from different fields. And again, I think there is also very good arguments that the way there is this notion of co-production from Razanov, this notion that the way you produce knowledge also produce tools to it's this notion of knowledge and social order, in a certain sense, are co-produced. And so if you include more diverse values, points of view in a certain sense, again, given certain epistemic constraints, then you can also enlarge the space of possibilities that are open to you. And again, the paradigmatic example is the mitigation scenarios that are very narrow in many ways, because they are based on a number of highly value-laden assumptions. That's fine. But again, increasing this window of values would increase the assumptions you're considering, would increase the space of possibilities, future paths and mitigation paths and so on. And I think this is also one way to address a little bit your worry and your question.
Yeah. Thank you.
Welcome. Thank you for the question.
Well,
yeah, actually, it's really a follow-up, perhaps, of the previous question. So I found it very interesting what you said about climate modeling, that you are modeling your modeling process, a lot of semi-empirical inputs, and so you have to optimize your model for certain regions of the Earth or certain aspects of climate. I mean, and it's reasonable to assume that would be always necessary to some degree. It's difficult to imagine a model that's so perfect that it wouldn't require some degree of calibration, which then would bring in a certain kind of emphasis. Now, my question is, to what degree are climate scientists taking this on board and being more explicit up front about the calibrations they're making? And especially given the increasing number of climate scientists from the South and from China, India, other places like this, and also going forward, say 10, 20 years from now, how would they behave differently, or how could they behave differently, ideally, in a way that would genuinely help?
Yeah, thank you for the question. This is a very, very, very important question. Here is a paper. I think this one, 2017. It's called "The Art and Science of Climate Tuning" or something like that. And it was a little bit. The title was a little bit controversial because there was this notion of art, of being an artisan in a certain sense. So but as you see, it's quite recent, 2017, and so it's starting to be. It has always been there, of course, but it's only starting to be explicitly acknowledged, I think, increasingly so. But I think depending on, the climate science community is a huge community, and depending on who you ask, will get different answers. But typically, the climate scientists I'm working with, and of course it's biased because typically the climate scientists who are ready to engage with philosophy of science and so on. So these people are typically extremely aware of these questions and are trying to push, typically for the kind of initiatives I mentioned with My Climate Risk, trying to include the interests, the values of the people who will be impacted by the adaptation measures based on the climate scenario. Typically, I was discussing with a colleague from the Global South, and she was mentioning that there is this notion of tropicalization of climate models. Typically, they don't have the means to develop their own models. So what typically happens is you take models from the global north, because most of the modeling centers are still in the global north, and they have a history, of course. And it's very difficult to trace all this history, the past choices, the past calibration that we made 10 years ago, and so on. There's huge construction. Nobody has an idea of all these choices and so on. So there's a number of these people are using these models, which are typically parameterized for the global north, for global north regions and so on. And then you downscale them and you use them for global south regions because they don't have the means and nobody wants to fund developing models only for these regions. So still nowadays you have an impact. So these questions have an impact. So to answer your question, I think it's depending on who you ask, you get different answers, but it's, I think, increasingly acknowledged, and that's something must be done, especially when it comes to adaptation. The big topic now is adaptation to extremes and so on, and you can have really big differences, big influences of these questions. Again, some of these choices, it's not about like modelers in Hamburg, but also they're explicitly saying, okay, I want to optimize for Germany or for my hometown in Germany. Not at all. Sometimes, as Wayne Parker argued, it's just pragmatic choices. But in the end, the end effect is that some of these models will be better for certain variables, for certain regions of the world, and so on. And these need to be acknowledged. And it also has consequences nowadays. An interesting debate recently is that some people had the expectation, because now the big thing is machine learning, of course, and some people have the expectation that machine learning methods replacing parameterization, that's what people now are doing more and more. It's a big thing in weather forecasting, because there you have you can there is every 6 hours basically you can validate your model and update and so on. But climate models is an entire different beast and story. But still, machine learning is more and more used typically for parameterization, also just for computational costs. It's much cheaper. And then there were a few people putting forward the idea, gesturing at the idea that it's more objective in a certain sense because you're using machine learning methods, and then you don't need all these calibration choices and so on. And then with a number of colleagues, and we're not the only one, there are excellent arguments saying that, of course, machine learning methods also involve a number of value-laden choices in this huge parameter space they are working in and so on. So you just displace somehow these value-laden dimensions, but they are still there. But back to your original question, I think it's increasingly acknowledged, this dimension. And the thing is, it's not easy to remediate. It's not like you can build from scratch a new model. Nobody will do that. No funding agency will pay for this. So we are inheriting the models from the past with their embedded choices and pragmatics and so on. You have to deal with this. But then you have to acknowledge that there are going to be differences and so on. And it does have also very concrete legal financial consequences. For instance, if you think about the big thing is climate litigation, these kind of questions, it could be based on certain outputs from climate models. Think about again when it comes to responsibilities, when it comes to extremes and so on. But again, depending on what type of extremes in what regions of the world, then you could have different outcomes and different chances to have a meaningful data for litigation purposes, for instance, depending on what region of the world. So yes, it does have a huge impact, and I think it's increasingly acknowledged, but maybe not by everybody and not everywhere in all the subcommunities of climate science. But it's a big topic.
Can I just follow up briefly?
Yes.
This kind of relates to a worry that a few people have mentioned, which is there would be a way for a climate modeler, for example, to say, look, I've carried out various optimizations for certain regions of the world, let's say, and that could be interpreted like a very pragmatic calibration process that just has to be done. But when you start talking about values, there was saying that there are certain values that have maybe certain interests in certain parts of the world, like a human interest.
Yeah.
Then that starts shading into a particularly problematic territory where a climate scientist might feel very uncomfortable to come out and say, look, as a human being, this is the sort of thing that I'm concerned about.
You're perfectly right. And I think that's also, and I think it's so on.
No, I just wanted to say, so it's also, I think, important to find a way that they can, almost like a report card that they can give, like to say, look, very pragmatically, these are the optimizations I've done, and why, without talking about necessarily why I've done them. Right?
No, you're perfectly right. I think that's also exactly what you mentioned is also one of the reasons why a number of climate scientists are not very comfortable with this in the first place. And typically in this paper, these are climate scientists specialized in parameterization and so on. One of their proposals is just to document all the choices that have been made, because we don't know now the past choices, and this is highly problematic. But yeah, exactly. But then I think, on the other hand, at least people coming from the humanities and so on, having a critical look at all this, we shouldn't be scared of saying, yeah, I mean, all the modeling center are in the global north. It does have an impact. It would be wrong not to say that it has no impact on the type of outputs that these models produce. But it's not a simple dichotomy that you can maybe have the impression from what I said, because typically there are very important topical processes in the south that are crucial for understanding the climate of the global north, of course. So it's more entangled always. But in the end, all these choices do have an impact, and we need to acknowledge this, I think. And again, there is also the big question about the data. The data we have in order to calibrate the models and so on. Different regions of the world have different historical data. In the global north, for various reasons, we have a wealth of data. In the colonies, we have a wealth of data. But in other regions, certain other regions of the world, we have much less data. And this is, I mean, there is a very good, just very briefly, I can show you this from the IPCC, from the latest report. It's quite impressive, very quickly. Sorry for this. Very nice. I had a few, this one. This is from the latest IPCC report. The details, this is, so they divide the world in regions like this. Look at this here. So this is the synthesis of observed change in heavy precipitation, so extreme, quite important. Confidence in human and contribution to the observed changes in world's regions. Green is increase, it's clearly increase, so the points here are high confidence, medium confidence, and gray like this is limited data and or literature. And you see the limited data and or literature is mainly in the south. And this is not because the physics is more complicated or because it's because we don't have the data. Because there was lack of data and people cared less about this region, blah blah blah. There's a number of stories to be narratives to be told there. But you see, it has still an impact. And precipitation is extremely important for many reasons, of course. And this is the latest report from the IPCC 2021.
Okay, let's thank our speaker once again. Great job.